Hello everybody, this is Scott Shawcroft, and I'm the creator of FlightStack. I have a company called, soon to have a company called Chickadee Tech that will produce these boards called the FlightStack. What FlightStack is in a brief overview is you get this is a flight controller for a racing, typically racing quadcopter, although it could be more generally used for any RC aircraft. And the innovation is that it allows you to it uses a high density connector to give you more expansion possibilities than you could ever have before from the microcontroller. For example, this is the F3 based FC, and it has 5 hardware serial. Anything else on the market today only has 3, so 5 is greater than 3, which hopefully means better. So what you can do is you have this high density connector instead, and this is an expansion. This expansion breaks out serial ports, and so you can just snap it on like that, and you end up with a stacked system. What? Vin? Kitty's talking to me. So now you can have 2 serial out here. You could actually have a second double serial board and get 4 straight out. Pro tip, when you're removing them, pull straight away. These connectors, one of their weaknesses is they're not rated for a bunch of mating cycles, so you got to be careful there. So what we're doing today, this is a revision 4 of the board, and this board flies, which is awesome, but there was a few things that I wanted to change with it. So what we're doing today is we're going to be doing a revision 5, a version 5 of the board. This is what the board looks like straight from Osh Park. And I have a magnifier, so that might make it a little bit easier to see. So this is the V4 board, and this is the V5 board. Now I'll turn them so you can see the differences. You can see there's a lot of standard layout stuff that's the same, like the LEDs and things. Some of the things that I changed, some silk screen things, like putting the FlightStack logo. Also swapped the MPU 6500 for an MPU 6000. And I also shifted the ESC holes over a little bit. That will allow for better clearance below it. And then I'm trying to think of all the things that changed. The backside looks pretty similar. One thing I did remove is I removed the voltage divider because all power boards will have the voltage divider on them instead. And obviously the ESC holes got closer to the transistors also. So that's what we're going to do today. We're going to solder it up. This is just going to be a first part. I like to solder in chunks because soldering for 5 hours straight is not very fun. So in this first part, what we're going to be doing is basically soldering all the hard stuff. And all the hard stuff is the things with high density that it helps to have a good perspective on making sure that everything gets soldered right. So I always start with these tall connectors because they have the finest pitch. Pitch is the distance between pins. In this case, this connector is 0.4 millimeter. And then the next thing I do is the 0.5 millimeter pitch microcontroller. And then I'll do the gyro accelerometer because that requires some hot air. I'll also do this connector here for the same reason. And then I'll do all the other ICs, so these and that, and the crystal probably. And then part 2 will be all the passives, so all the capacitors, resistors, and the LEDs. And then lastly, I'll do the connectors like the USB and the button. It's going to be a few hours, so prepare yourself. The reason it's going to be long is that I'm actually going to do another board also at the same time. This is the first version of an F4 based board. So these are kind of high-level lines that STM provides. The F3 run is clocked at 72 megahertz, while the F4 varies a little bit, but the one that I'm putting on here is 168 megahertz. So you get a lot more processing power. It also gives you one extra hardware UART, which is cool, so a total of 6. And this is the first version. I haven't flown it yet. Obviously, I'll put race flight on it when I get the chance. But these are similar enough that I'm going to do them at the same time. That way, when I pick out, this component here from all of my components, I can just put it on both at the same time. So that's what we're going to be doing. I will put these ones that are finished. I'm hoping the cat is above me. I'm hoping she doesn't knock things down on me. So before I get started, let's talk about tools a little bit. I have magnifier. I haven't soldered with as much yet. I just got it, so we'll see if I end up using that. Hopefully that makes it also easier for you to see some things. The reflection is that there's LEDs right up here. I also just recently got a fume absorber. Looks like this kind of. That's nice. It should absorb fumes so that I don't inhale the flux fumes as much. It will be noisier, so it may be harder to hear me. These are flush cutters / side cutters. These are just generally useful for cutting things. This is solder wick. This is useful for removing extra solder. I always put too much. This is a water-soluble flux pen, which makes soldering way easier. Also, you'll see me use it all the time. I've got a pair of safety glasses. You don't want to splatter yourself in the eye with solder. That just is no fun. I'm switching. This is the second time I've used this solder. This is SparkFun's lead-free special blend, which presents some challenges. I was soldering with it yesterday. My iron is turned up, so I have a Hakko iron, and I'm running it at like right around 400. Just means you have to be quick. And then the tip I'm using is a special like elongated small chisel tip, and I find that this works best for almost all of the stuff that I'm going to be doing. I have a conical tip, a small conical tip, and I'm really only using the conical tip for stuffing into header holes when I'm wicking solder away, when I'm removing solder. Yeah, so I've got a Hakko iron. If I need to change a tip, I've got some needle nose pliers because tips are hot. Boards are from Osh Park, designed with KiCad, which is open source software. I've got off screen here. I've got a hot air gun. I'm not exactly sure what temperature I'll be running it at because I haven't done any hot air work with the lead-free solder. And I've also got a pan of ice junior, which is just really awesome. It's very useful when doing these 36 millimeter boards. And then I've also got off-screen. Excuse me. I've also got off-screen bags and bags and bags of parts. These silver ones are the MCUs, the microcontrollers. I've also got the high density connectors. I've got a whole bunch more sorted in a binder. To help me figure out what I need, I've got BOM, which is a bill of materials for each the F3 and the F4. Basically what I'll do is I'll do all the common parts between them first. Well, sort of. Which should make things easier. Because like for all of the 0.1 microfarad capacitors, they both have a bunch of them. I might as well do them all at the same time. Those are all the parts. I think I'm getting a cold, which is great. So the first step, when you get the boards from Osh Park, they're held together on a larger PCB panel by these mouse bites, or I forget what the other term is. But the first step is to cut them off. So I've got a garbage here, and we'll cut them off. I just use the side cutters for it. Make sure you're wearing your safety glasses too, because you can shoot them everywhere, which is no fun. So I'm just trimming them off so they're not sharp. They don't have to be perfectly flush. I just don't want to snag anything. So there's one. Not perfect, but it's okay. Oh, a little bit of chunk out of that. What do you want, Ben? We'll see how this goes. I have a cat on my lap. It's gonna go well until I have to get up. That's okay. Alright, don't need these. Turn on my iron. So I'm going to start with the high density connectors receptacle, which is what goes on top of the board. And I started marking every board with the height. Not sure if you can see it. These both are 3.5 millimeter. That height takes into account 1.5 millimeters allocated to the thing on top of it. That way the thing on top can have components on the bottom side. So these boards are only actually like under 2 millimeters tall. So turn this on. Hopefully this noise is not too much worse. But I really should get a lapel mic probably. I'm just gonna get some. The solder is kind of funny. It smells kind of like cotton candy. Careful. Don't make me kick you out. So the technique that I use for this is I flux it up, and then although I usually tack and reflow, which is like putting solder on the joint. Oh, that's what I need. I need tweezers. I like to have at least 2 pair of tweezers out whenever I'm soldering. And the finer the tweezer, the better. Because components that are right next to each other can be hard to hold if your tweezers are not fine. Alright, I got 2 pairs. I have straight and I've got curved. The cat decided she didn't like the noise. So the way I keep track of what I've got is after I use something like this, I'll set it to the side and then later I go through and count how many I have. Kind of keeps my inventory current. So the approach I like to use is, just because I'm tacking it down, I don't need to have a ton of solder. So I actually like kind of get my solder just sticking up so that I can grab some of it without having to actually hold the solder itself. So I'll place it there. Now the trickiest part is that the board isn't actually flat. The copper pads or the gold-plated pads are actually raised a little bit. So when you're shifting it around, you may actually have to lift the connector up. That looks good. So all I do is I hold it with one hand, and then I take the iron, get a little bit of solder on it, and I just tack. First joint of the day. More flux. So I nudge it a little bit. Just trying to move it back a little. Okay, so I did one side. It's not tacked very well, so still be careful. And then I go the opposite corner, and I look to make sure everything is lined up. It's actually not lined up that well. It's better. And then I'll hold it down. Flex underneath. And now I'm tacking the opposite corner down. When you're tacking like this, the most important thing to remember is when you're going to do the rest of the pins, don't start where you tacked it off, otherwise you'll just cause it to shift again. So this alignment is not spectacular, actually. I think it's good enough that it'll be alright though. So now that it's tacked down, what I do is drag. The technique is called drag soldering. So you just put a bunch of flux, and then you get a little bit of solder on your iron. This is why I like the triple tip. And then you just drag from pin to pin. Now I notice that the drag speed that you have to do for lead-free solder is just a little bit slower than it is with leaded solder, and that's because the melting temp is higher, so you have to put your iron on there just a little bit longer. So just gently kind of drag from pin to pin to pin, and if it doesn't seem to be behaving, you can always put more flux. More flux. And I like water soluble flux because it is alcohol soluble, which means that you'll be able to clean it off. The no clean flux is just kind of goopy. And it leads to a board that's very gross, I think. So I'm just running back and forth trying to get what I'm running into is that kind of the problems that you hit with lead-free solder are the same ones you get with leaded solder. It's just that they're more prevalent. Like, it's always harder to solder ground because ground is usually connected to a lot of copper. So when you're soldering, you have to heat up all that copper to be able to get everything to melt. And with lead-free solder, you just have that little bit more temperature that you need in order to get it to melt. So now I'm just gotten most of the pins okay. I just have a little bit of a solder bridge at the very end. And when you lost my train of thought. I don't remember what I was saying. So I've done one side, now I'm going to go back and do the other. Same technique. These tiny pins take so little solder that I don't even bother holding the solder. I do like to end up with too much solder on the joints because that way I know that I've gotten enough. If you don't end up with any extra solder, then there might be a pin that actually needed some more. And use the reflection of the solder to your advantage to be able to tell whether you have a bridge or not. Good. So that's on there. The nice thing about the gold plated is also you can more easily tell where you have solder and where you don't. Like if you're getting a gold reflection back, you're obviously don't have enough solder on a pad. So again, I flux down, put some obviously this is not how production will be done. Production will be done with a picking device. So remember, this first joint that you do, you want it to be small enough that you can heat it up with your iron to move it if need be. Trick is holding it down with your finger while it's still on the pad, because it wants to roll off the pads onto off of the pads between, so that they're between the pads instead, because between the pads are slightly lower. That's pretty good. So now I've tacked it down barely, and now I'm checking out the alignment, because after you start doing a bunch of pins, either you're going to need a hot air gun to redo it, or yeah, you're just going to need a hot air gun. I don't know any other way to do it. With a soldering iron, you can only heat up so much at a time. I got enough of this side that I can just finish it. It all looks well aligned to me. And bridges are fine here, just take your time, be gentle on the pins. Since I'm using lead-free solder, you have to be extra gentle because it takes just a little bit longer for the pins to hit up and the solder to reflow. And of course, flux is your friend. And I'm not removing all the solder when I do this, just enough. Just a little bit. You don't want to remove it all because then you won't have any on the joints. So I just make the bridge smaller and then I'll reflux it. And run over it again. The flux helps the solder run into where you want it to. If you have just a little solder, sometimes you can just pull it off with your tip. Good. Now we have to do the other side. Yep, the ground pins are definitely touchy. I'm just slowing down a little bit as I go over them. It's just a smidge easier to, or it gives it just a little bit more time to heat up. And that side looks good. Okay, now I'm gonna do this one. So this is these connectors are pretty cool because the header, which is like the short thing that goes on the underside of the board, is shared. It's always the same height, but the receptacle, which is what the header goes into, can change in height. So the board, every board can actually decide how much space on the top side it needs by just picking the receptacle height that is most appropriate for it. So like I was saying earlier, these boards need to be, they need 2 millimeters of height. So their receptacle is 3.5 millimeters. And that's, again, so that you can have, on the inside of the board at least, you can have up to 1.5 millimeter. That's good. Got an email and everything. I find the headers easier to solder because they have larger legs. Is that the right term? I always, after I do the solder wick, I always go back to flux it one more time. There we go. So this 20-pin connector is actually used just for power. So we assume that the FC is on the bottom, and then the power flows through this connector. Although each pin is small, like multiple pins have been designated for a particular voltage or rail. So like all but one of these pins is battery, for example, and then the other side is all ground. And each pin can do 300 milliamps tops, which means you can actually do somewhere around 2 total amps. That one's good. This is a bug that I want to fix on V2. You can see here that I actually left the ground plane, or the copper pour, over all of the ground pins here, and this is because it's going to make it a little bit less clear when I get it soldered well. So that won't be in the real version. I keep track of like the stage of every version in a Trello doc, and so it's like even hard to see if it's lined up correctly. It's just an artifact of one of the things I learned along the way. That's pain. Electrically, it doesn't matter, but I guess not as much. Like, I also want to get it on there straight. It's much easier to see when you have straight pads to compare against on both sides. This is an example why I don't tack it down first. It's like once you get some solder on there, it's quite difficult to nudge it to where you want it. Now it's just straight up too far over. Ugh. Failure. Surprise, surprise. If I wrench it too hard, I'm gonna bend. There we go. That looks good. Whew. Got it. Kind of looks like I melted it. Just a little bit. What makes it worse is I'm doing it over the ground plane. There. We'll call it good. We do have a little bit of play in the connector, that should help. Love it when I get it first try. That side was so much easier. Go figure. So the goal with any of these prototypes is to figure out all of the things that I want to change in as little, well, for every iteration I want to find as many things that I want to change as possible, which will hopefully lead to the minimal number of iterations. So just because I don't like this stupid thing, I'm not about to rush off and order a new prototype that just fixes that. I want to try and fix as much as I can from the get-go. Well, for every iteration I want to fix as much as I can. Okay, so I've done the connectors, both of these. Now I'm going to do the microcontroller. Or not. I think I changed my mind. What I'm looking at is in here, if I put the microcontroller, I'm going to have a tough time seeing exactly what the MPU 6000 is doing. So I think I'll actually do that first. The microcontroller is much easier to see how successful you've been in soldering it. So let's do some hot air work instead. So what I do when I'm doing the hot air is I just do a little bit of solder on everything. And we'll see how it goes with the lead free. Probably gonna have to definitely bump up the temp on the hot air. Alright, so these are the MPU 6000s. Previous iterations have used the 6500, but Motomoto pointed out that these are probably better, so I switched. We'll see. They are end of life, but they cost the same on DigiKey, and the stock is about the same. So, figured I'd try them. It's not too difficult to switch between the two. This switching to the 6000 was slightly more difficult because it takes more board space. But if I ever did have to switch back, I wouldn't be too worried about it. You know, I could end up regretting that. So what I'm looking for here is I'm looking for here's the circle for the first pin, and the first pin is also where the corner's been cut out. And the nice thing about the big one is that it's easier to see. already melted. Now it's just a matter of, well, it stopped being melted. I didn't put too much solder. I like to tap the top. That looks really good. So my only real goal with using the hot air is to get it placed and get the bottom pad soldered on. These side pads, what I like to do is actually just run over them with a little more solder and make sure that they're connected. One of my early boards didn't have it connected, and once I just ran over the sides again like this, it worked. So that's why I like to go back and just do a little bit more. You can see I got some extra solder in capacitor 3. That's not a big deal. I'll probably take it off one side of that just so that I... Well, that's the advantage of the 6000. That was even easier than the 6500. It's an extra 1 millimeter in each direction. Which is just enough to make it better. I'm just going to do the same technique. Oh! Parts go flying. That's how you know it's not soldered. You blow it away. So it is liquid. I like to just tap the top in case you get too much underneath. And what tapping will do is it'll actually cause it to squirt out the side. So here you can maybe see, oh, it's hot. Beware that when you're doing hot air, you're heating up the whole board. But I don't know if you can see that, but there's a little blob of solder that kind of squirted out. And the nice thing is that it should be soldered well underneath, and now I can just go over it with my iron and get that all straightened out. Like that. And again, I got it on the capacitor. Woohoo. Yeah, these are easier to solder. That's nice. That looks good. Alright, next up we have, this is one of the trickier parts. These are all the common parts, but now I want to do the microcontroller. And they have different microcontrollers on them. So, this is the F3. So here I'm going to do more of a traditional, actually no, that's not true. I'm doing the same thing. So again, like I'm getting it stuck in between the pads, so just know that, don't jam it, you don't want to bend any pins, but it's amazing how much easier it gets just a little bit larger pin pitch. And solder's down here. Just tack the corner, make sure it looks okay, which it does. This is the F3 board with an F3 chip on it. Good time to check that. You can take the chip off with a hot air gun, but it's not easy, especially if you want to reuse the chip later. I'm just drag soldering all of this. One more flux pass. find drag soldering so satisfying. The flux, you get a little bit of a psh noise. I doubt you can hear it. And you just do so many joints all at once. It's exciting. And lastly, the side we started with. I hope this is semi-interesting. Probably not. Watch somebody solder for 5 hours. There we go. Looking good. Now we need our F4 board. I haven't done any of these, so I'm excited to try the F4 board. I'm hoping it works. May not though. I'm already on, I just did revision 5 of the F3 board, but I did learn a lot with it. So hopefully it'll work. I mean, the very V1 to V2 of the F3 was just because I didn't have I2C pull-ups, which I realized before I even got the board back. So I ordered V2 before I even had done V1, which is not really the way to do it, because like I was saying earlier, you haven't optimized for figuring out all the problems. That being said, I was on vacation, so I had time to wait anyway, so I just did it. And then V2 to V3 was breaking out the SWD lines. Turns out you can't get it going if you can't do the SWD, because you can't do the USB boot loading until you've already loaded one version of software on it. And you have to do through the SWD line. So that was V2 to V3. I don't remember what V4 was. V4 was the one that, oh, V3 didn't have, I wanted to focus on getting the microcontroller working, and I was thinking about, you know, if you want to upgrade from V3 to V4, you know, a lot of the expensive of flight controller is the NPU. So I was playing around with the idea of having the gyro and accelerometer on a different board, but so I did that for V3, and I actually flew V3, but I wasn't very happy with that idea, partly because there's like an overhead to every board because they need the high density connector and the supporting infrastructure, the supporting circuitry for that. And so I So V3 didn't have an accelerometer and gyro on it. It had it on a separate board, which turned out to be a huge pain because clean flight doesn't work very nicely with that. Looks like I bent some pins while I was talking. It's most unfortunate. Where I'm going to switch to the fine tip, and I'm going to hope that, actually, I'm going to do the rest of it first and then fix that. Flux. Looks like I bent 3 pins. I should be able to salvage it by turning them back. I'm using needle nose pliers because this is hot. Kind of a pain. Some people have two. 2 separate irons, one with a fine tip, but I am on a budget. Until I start selling these things. I'll probably only use this tip just to fix it up. Everything else is harder with it, because of the way it doesn't hold solder very well. I can't believe I did that. Oh! I think I destroyed it. No dice. I was trying to push it over and I pushed the whole pad. Good. What pins are those? Let's see what I screwed up. Well, bad news. One of these pins that's bad is the boot pin. And the boot pin is definitely needed. I can't believe I did that. Alright, here's a stab at taking this off. I think if I can take it off, straighten it out, go back. So I definitely lifted a pad, but I think it's still connected. Bumping the temperature just up a little bit more. Can't believe it. Oh. Don't pull it off too early. Don't pull it off too early. Bingo. Now let's let it cool. This pad here is you gonna help me, Ben? Huh? You gonna give Dad a hand? Now what I'm gonna do is I'm gonna clean up all the solder and try it again. No, and now I have the tip that I don't want. The small tip doesn't hold very much heat. So basically what I'm doing is I'm starting over on this, and I'll should be easier to bend the pins back to align with the pads. I don't think the pad that I lifted is actually critical. I don't think it's boot. I think it's an I2C line. If I end up not doing it, it's okay. It's not the end of the world. Hey girl. Yeah, I think I screwed up an I2C line. Not the end of the world. The boot is a non-starter, but using an I2C line, I haven't even written the code to use it, so that's okay. The only thing I'm worried about is that I don't want to bridge the pins. Okay. Let's see if I can. Oh! I'm just gonna take this part off. It's gonna cause more trouble than before. So this is the mango pad that I messed up. I'm pretty sure it's the I2C line. Yeah. So that's the pad that it was straight. I curved it. I just ripped it right off. So the I2C won't work on this board, but that's okay. What's more important is fixing this. My other alternative is to use another microcontroller. They're like $10 a piece. There we go. Bingo. Now it's even harder to get it positioned because it's not super duper flat. This is the remaining solder that's on there. Money right there. Take two. Okay, opposite corners. Side looks like it went well. Time to do the side I screwed up. Now one of these won't solder because I ripped the pad off. That looks good enough. Should be able to boot. Bingo. All right. Whew. So let's see, we're an hour and a half in. What's next? We'll do passives later. So let's do all of the non-passives. So I think we've got a voltage regulator here, which is similarly placed over here. And then we've got, on the back we've got a diode, O-ring diode, and 2 transistors. That's all we've got. Let me look. O-ring diode, MOSFET. We did the gyro, we did the regulator, resonator. Okay. picked the transistors, so we'll do those first. There's 2 in each board. These are part of the magic that makes the reset button awesome. Meaning those reset buttons you have to push down while you're plugging it in, because like a button like that just changes the bit. It tells it how to boot. You still have to reset it. But I got this circuit from Baushi. I don't know how you say it exactly, but he came up with a circuit where if you hold it long enough, it'll reset automatically, or it will lower the boot selection and then reset. So on these boards, all you have to do is like this says, short reset, long press for the bootloader, which is great. So this is more than your traditional tack and reflow. So I'll tack them in one spot and I like how they're labeled Q3 and Q4, but there's no Q1 or 2. When I do iterations, I don't change the labels. So at some point I had a Q1, Q2, but I don't remember what they were for. Probably should have moved Q3 over here. It's quite close to where the header is. I'll have to check that clearance out later. I can cheat it a little bit. Place it. That's one of the downsides of Flex. Sometimes components stick to your tweezers. Almost there. Just have voltage regulators and diode to do before we're on the passives. So these are the voltage regulators. I made the mistake of doing the voltage regulator after the big capacitor that goes next to it. And that's tricky. I was gonna do the crystal too. And I'll have some lunch. And that's getting kind of late. I think it wiggled a little bit because that free solder stays liquid just a little bit longer than leaded solder. This wasn't quite patient enough for it. I do like the orientation of this better though. Next is our diode array, which is what keeps USB power from going into the battery power. No, it keeps the battery power from going to the USB, and vice versa. Is on the bottom. I could look this up, but it's similar enough to previous iterations of the board that I'll just do this. that I know where it is. When it comes to like all the different capacitor values and stuff, then it takes some work. You don't really have to do this one that early because there's nothing around it. That's how I'm structuring the videos. So this one is going to come in at right around 2 hours. The bonus footage of redoing that microcontroller, which I had not planned. That is that. Getting ahead of myself again. There we go. And the last thing I was going to do is the crystal. It's not actually a crystal, but it's a resonator, which means it has the loading capacitor. Oh, mouse overboard! Crystals are, these resonators are really tiny. And I think that they can both run off 8 megahertz. I'm going to be kicking myself if the 8 megahertz doesn't work. Yeah, I will definitely kick myself. I don't remember checking that actually. I hope the F4 can have a 8 megahertz external oscillator. If not, it's not going to work very well. Maybe I'll look that up during lunch. The footprint, I should be able to get just a different part and put it on the same footprint. Actually, maybe I'll look that up before I solder it on. This is the last one I'll do. I'm gonna wait. I may wait to do the other one until I look it up, just to double check. Or not. I can always just hot air up. Hot air off. There we go. One leg. One of my earlier versions had just a straight crystal. And then I had to do like some teeny tiny 27 picofarad capacitors to load it. It took a lot more space. And it costs like just, I think actually a little bit more than this does. So credit to the new CC3D forum thread where they pointed that out. This is what lots of people are using. Oh, sometimes I have the worst luck flipping something over. There we go. And the orientation of this doesn't matter. As long as the middle is the middle. More flux. I think it's on there. That looks better. Everywhere except where I need it. That's annoying. This one's giving me trouble. This might be easier if I had that fine tip on there. Well, that side was easy. Place it right in the middle, that's my problem. Okie dokie, so we've got 3 minutes till 2 hours, and let's just do an overview of what we did. So we started with the hardest thing, which is the fine 0.4 millimeter pitch. I can see I bumped it some. Might be a little tight. The high density connector, we did the bottom part of it too. And then we went on to doing the MPU 6000, which was way easier than the 6500 to do because it's larger. And then we did the microcontrollers. And the microcontrollers, the F3 turned out to be easy just because I did it well. I bent some pins here on the F4 and that made it more difficult, so I took it off with a hot air gun and removed all the solder, bent everything back, and hopefully salvaged it. I2C won't work because that's the pin or the pad that I screwed up, but everything else should be okay. I did the MOSFETs for the reset circuit, I did the diodes for the power management, and I did the regulators. So when we come back after I have some lunch in part 2, we'll do all of the passives, so that's all the capacitors, all of the resistors, and we'll do the diodes as well, so all of the LEDs and stuff. And since there's not much else besides that, at the very end of that video we'll probably do switches and the USB. So tune in later, probably about an hour, and I'll finish those up. Then once everything's finished, I'll then be able to test, which will be exciting.